This unit is going to be about circles. And circles are almost as useful as triangles in the real world. And when you think about circles, I want you to think about space and astronomy, because a lot of what we're going to be using with tangents and secants are used by astronomers when they are studying bodies in space. Anyway, let's look at some vocab. A circle is a set of all the points in a plane that are equidistant from a given point called the center of the circle. So, circle is just the round part. A segment whose endpoints are the center and any point on the circle is called a radius. A chord is a segment whose endpoints are on a circle, and a chord that goes through the middle of this, or the center of the circle, is called the diameter. Now I have a diagram that I'd like us to fill out with these terms. As you can see, we've labeled the diameter, a radius, and a chord. I'd like you to fill that out on your sheet. And notice that the diameter is a special type of chord. It goes right through the center. Pause the video if you need time to write this down. Now, a line that intersects a circle in two places is called a secant line, or a secant. A line that intersects a circle in exactly one point is called a tangent line, or a tangent. The tangent line intersects at what is called the point of tangency. So I'd like you to fill all of those out and then label this diagram with secant line, tangent, and point of tangency. All right, so let's use some of these. I have a diagram here with a circle and some lines, and I want you to describe each of these line segments. So if I look at line segment DE or DC, which would be right from here to here, that is called a radius. If I look at segment BD right here, you can see that that is called a chord. If I look at segment DE, that's this whole great big long one here, that is called a diameter. And lastly, if I look at line AE, the entire line, that is called a tangent line because it intersects the circle at exactly one point. Now I want you to tell me why line segment AD, why line AD, this line right here, is a secant and not a chord. Well, that is because AD does not end at the circle. It continues on, it cuts through the circle and keeps on going. So it is a secant, not a chord. All right, let's use some other vocab. I would like you to, looking at these circles, to give me the radius of circle B. Now to do that, what I'm going to do is circle B has a center at B. Sorry, and we didn't talk about how to name a circle, which is one of the things that we need to talk about. To name a circle, you use the center point. So, and if I have a dot with a circle around it, that notation reads circle and then whatever letter is after it, circle B. So in A here it says find the radius of circle B. So I know which circle they're talking about is the one that has B in the center. And the radius is from the center to a point on the circle, so that's 1, 2, 3, 4 units. 1, 2, 3, sorry, counted wrong. 1, 2, 3 units. My bad. Now, if I want to know the diameter of A, I have the circle that has A in the middle, and I go across that circle, and I see that has 4 units. If I want the radius of A, I go to the center of A, and I go to the circle, and that is 2 units. It's also half the diameter. So the diameter of B would be all the way across the circle that has B in the middle, and that is 6 units. All right, so now you know how to name a circle and find the diameter and radius if it's in a coordinate plane. There's also things called coplanar circles, and sometimes they have 2 points of intersections. One point of intersection, or no intersections. If coplanar circles, that are circles on the same plane, intersect at one point, they are called tangent circles. So on your graph, make sure and put a little star by tangent circles, because they touch at one point. If they don't have any points of intersection, they might be what is called concentric circles. Whoa, sorry. And concentric circles have a common center, so it would be like this one. These 2 circles are concentric. Coplanar circles can also have common tangents. These lines, segments, or rays are tangent to each circle. So if we look at our first one there, you can see that I could draw 2 common tangents on the outside of those circles. And so they would have 2 common tangents. The diagram in the middle, I could actually draw 4 common tangents on that one, and the last one I could draw 3 common tangents. All right, so pause your video and write those things down. Now, a line is tangent to a circle if and only if the line is perpendicular to a radius at the point of tangency. So in this diagram, line M is tangent to circle Q because it forms a right angle at P. All right, let's look at this. In this particular diagram, line segment AB is the radius of circle A. And I want you to tell me if line segment BC is tangent to circle A. Well, I know that AB and BC must be perpendicular if they are tangent, which means that they must form a right angle. And using Pythagorean's theorem, I can test to see if these are indeed, if this does indeed make a right triangle. So I'm going to label my diagram with my A, B, and C. Remember that C is always my hypotenuse. And I'm going to plug in my numbers. For A, I guess I did this backwards. For B, I put 60. For A, I put 25. And for the hypotenuse, I put 67. I squared all of those. Then I simplified, and I found that, 4,225 does not equal 4,489. So line segment AB and BC do not form a right angle. Therefore, BC, line segment BC, is not tangent to circle A. Okay, you're welcome to go back and listen to that and look at that again. All right, let's take a look at this one. In this diagram, S is the point of tangency, and they are telling me that it is tangent at that point, and they want me to find the radius of circle T. Well, I know if S is the point of tangency, that S has to be a right angle, therefore this is a right triangle, and again, I'm going to use the Pythagorean theorem to find my radius. So I'm going to use a squared plus b squared equals c squared. I'm going to label my diagram, and then I'm going to plug things in. My A is r squared. My b is 48 squared. But now look at my hypotenuse here. It's made up of this whole thing. So it's r plus 36. So r plus 36 squared. Now this is an expression, so I would need to then simplify that by using FOIL. And I think you guys remember this, where I get r squared plus 36r plus 36r plus 1,296. Then I'm going to put that in my equation, my simplified equation, and I'm going to solve. Now, this looks a lot harder than it is, because the first thing I'm going to do is get rid of my r squareds by subtracting r squared from both sides, and that just literally eliminates them. And now I have a simple two-step equation I know how to solve by subtracting and then dividing, and I get that my radius is 14 centimeters squared. Now I need you to put a star beside this. It says tangent segments from a common point not on the circle are congruent. So D in this example is not on the circle, and it is tangent at A and B. So therefore AD must be congruent to BD. And I'm going to use that to help me solve this. I'm going to say, I know that since these two are congruent, I'm going to use some hash marks to show that, I'm just going to set them equal to each other, and I'm going to solve. Excuse me. And when I do, I get that x equals 5.5, sorry. All right, so now you have the basics of what your homework is going to be about, and I think you can go practice.